So in our last video, we talked about what are secant lines, what are tangent lines. So now it's time to figure out how do we find the slope of secant lines and tangent lines. Now the way we find the slope of secant lines is with our slope formula. You take your 2 points, y2 minus y1 over x2 minus x1. Great. But the tangent lines, that's the new part. So that's what we're going to be working on. Now the problem with tangent lines, and by the way, if you turn back to page 7 in your notes packet, you'll see this table here. And it says, as an example, let f of x equal x squared. So I've graphed a graph of x squared. And let us try to find the slope of the secant line between x equals 1 and the value of an x. So eventually, we're going to be answering this question. What is the slope of the tangent line at x equals 1? So eventually we'll be answering what's the slope of this line right here that's tangent at the point x equals 1. But the problem with trying to do that is, remember the slope formula? y2 minus y1 over x2 minus x1. How many points does this require you to know? Yeah, it requires you to know 2 points. We need to know 2 points. My tangent line is only showing 1. I only have 1 point at 1, 1. Now, maybe you could guess these, but you're not going to be accurate because we don't exactly know where this tangent line is going. So the problem with tangent lines is that we've only got 1 point. So what we're going to do, we're going to try to estimate the tangent line slope by using secant lines to help us get there. So I'm going to erase this tangent line, and we'll work on finding slopes of secant lines. So the first one says we're going to complete the chart, and we're going to try and find the slope of the secant line between x equals 1, which is this point right here. Hold on. Which is this point right here, the point 1, 1. And then different values of x. So at first I'm going to do at the value of x equals 2. So at the point right here, 2, 4. Then I'll fill out my chart. So if x is 2, f of x, or in other words, y, is 4. So then my rise is the y2 minus y1 part. So y2 is 4, y1 is 1, so 4 minus 1 equals 3. The run is the x2 minus x1 part. So 2 minus 1 is 1. And the slope of my secant line is whenever you divide y2 minus y1 divided by x2 minus x1. So in other words, 3 divided by 1 equals 3. So the slope of the line, the secant line that connects this point to this point, so the slope of this line is 3. Okay? Well, now, that's cool, but again, we're trying to estimate the slope of the tangent line at 1. So we're going to move this point that was at 2, 4, we're going to move it a little bit closer to the point x equals 1.5, which I'm going to estimate is about right here. Now, to find the y value, I can use my formula. So if x is 1.5, y is going to be 1.5 squared, and 1.5 squared is 2.25. So now I'm going to be estimating the slope of, the slope of this line, to try to get closer and closer to this tangent line. So let's see. So my y value would be 2.25. The rise is 2.25 minus 1, 1.25. The run is 1.5 minus 1, which is 0.5. And the slope is 1.25 divided by 0.5, and we get 2.5. So the slope of this line is 2.5. Okay, now let's move that secant line a little bit closer, or the point a little bit closer, and do another secant line at the point 1.1. So I'm going to guess 1.1 is about right here. So let me erase everything else. So now we're going to move even closer to the point where we're trying to get our tangent line and just make a secant line between those 2 points that are really close together. So when x is 1.1, I'll use my formula again to find the y. Y is 1.1 squared, and 1.1 squared is 1.21. So this point is at 1.1 comma 1.21. Now I'll complete my chart. The y is 1.21. The rise is 1.21 minus 1, which is 0.21. The run is 1.1 minus 1, which is 0.1. And the slope of the secant line between these 2 points is 0.21 divided by 0.1, 2.1. Okay, let's move even closer and then find the slope between the next 2 points. So instead of 1.1, now we're going to be moving to 1.05. So see how close I'm making these points now? 1.05. Now I need to find that y. Let's see, the formula is y squared. So y would be 1.05 squared. And 1.05 squared is 1.1025. So the y would be 1.1025. 1.1025. Okay, the rise would be 1.1025 minus 1, which is 0.1025. The run would be 1.05 minus 1, which is 0.05. And then dividing those two, 2.05. Now, I know we could keep doing this in, but I'm going to go ahead and fill this chart out so that we can make some conclusions. Okay, so I went ahead and filled these in. And if you notice, as our x values get closer and closer to 1, the slope of the secant line is getting closer and closer to 2. So what happens if we then try to draw a secant line from 1, 1 to the point when x actually equals 1? So let's say I'll try to draw a secant line through this point right here at 1. So 1, 1. So when x is 1, y is 1. When the rise would be 1 minus 1, 0. Run would be 0, because 1 minus 1 is 0. And 0 divided by 0 is undefined. So I cannot draw a secant line through the same point. That's not going to work. But I can draw secant lines through points that are really close and look at the slope that's happening between those points and notice, oh, that slope is really getting closer and closer to 2. Oh, it's approaching 2. So what is the slope of the tangent line at x equals 1? Well, I can't find it exactly. Can't find it because I get an undefined value exactly with the method that we're using, but I can estimate it. That slope to be about 2. So why can't you use to find the slope of the why can't you use this method to find the slope of the tangent line at x equals 1? That's because we get 0 over 0. We would be trying to find the slope between a point and itself, so that won't work. Secant lines use 2 points. Tangent lines use 1 point. So using the fact that x gets closer and closer to 1, the secant line approaches the slope of the tangent line. So what's our best guess for the slope of the tangent line of f of x at x equals 1? 2. We're going to guess because all these slopes got closer and closer to 2. That sounds like a limit, doesn't it? Miss Hackett really knows where she's going with this. All right, let's use an analogy. Let's say you leave home at 10 a.m. on a trip and arrive at 12 noon. The trip is a total of 2 miles. How fast are you going at exactly 11 a.m.? I have no idea. I don't know. IDK. Do you guys still write IDK for I don't know? I have no idea. And I don't know because I don't know what I was doing at 11 a.m. So we can't find the actual velocity at 11 a.m. That's called the instantaneous velocity. But I can find the average velocity from 10 to 12, and I can do that by taking the total distance, which is 100 miles, dividing it by the total time from 10 to noon would be 2 hours. So, oh look, my average velocity is 50 miles an hour. Now, I didn't drive 50, probably wasn't driving exactly 50 miles per hour at 11 a.m., but I could find the average velocity to be 50 miles an hour overall. So if you turn the page in your notes packet, you'll see this on page 8. You can mark off that chart right above it. We're not going to do that. But it says, now let's take a look at these 2 points with general coordinates x0, y0, and x1, y1. And we draw the triangle because we're trying to estimate the slope. Now the slope of the secant line I can find by taking y2, which they labeled as y1, y1 subtracting y0, and then x1 minus x0. That's our normal slope formula. Cool, secant line, got it. Now, let's focus on finding the slope of the tangent line. This won't work because we can't use the same method because we need 2 points for a tangent line. So, instead, we're going to define the variable h as a horizontal distance between 2 points P and Q. So, it could be any point. So, let's say I have this point right here. And h is the distance between them. And if h is the distance between x and this random point, then I can label this random point, the coordinates of this point, x plus whatever h is for the x part, and x sub 0 plus h, comma, and then to get the y, so we'll label this x plus h, x0 plus h. So to get the y, I would just do f of whatever that value is, f of x0 plus h. Okay, so now, since the secant line is the slope of y2 minus y1 over x2 minus x1, if I want to find the slope of the tangent line, I can start by the slope of the secant line by doing y2 minus y1. So I can do f of x0 plus h minus, now the y1 is labeled y0, but I want it all in the same term, so I'm going to call this f of x0, divided by x2, x0 plus h, minus x1, which is x0, x sub 0. And let me rewrite this part. So the x0 plus h is coming from here, x sub 0 plus h. And then there are some like terms here, x0 minus x0 cancels out. And so that does simplify to f of x0 plus h minus f of x0 all over h. And if this point moves closer and closer and closer and closer to point P, then that means the distance between this and the second point gets smaller and smaller and smaller. So as the distance between those 2 points get closer and closer to 0. So we'll say as h approaches 0. That will give us the slope of the tangent line. So as h gets closer and closer to 0. So h can't be 0 because remember we would be dividing by 0 again. So flip the page, or look at the next page, page 9. Here's formulas you need to know. Slope of the secant line, and then the slope of the tangent line is f of this minus f of x sub 0 over h as h gets closer and closer to 0. Now, since you guys already know limits, and I know that you know limits, I'm going to say that the slope of the tangent line is equal, I need to write it underneath it because I'm going to run out of space, the limit as h approaches 0 of f of x0 plus h minus f of x0 all over h. Now this x0, you're probably just going to see it as f of x. So I'll erase the f of x0s. So this is a formula you need to remember. This is how you find the slope of the tangent line. So you need to know the regular slope formula for a secant line and then the slope of the tangent line. So we have a couple of examples here. For the function f of x equals x squared plus 1, find the following and then confirm on your calculator. So we need to know the average rate of change. Average rate of change is the secant line. So average rate of change, slope of the secant line equals f of 3 minus f of 1 over 3 minus 1. And remember, slope is y2 minus y1. So this is saying I have the point 1 comma something and 3 comma something, and I need to find the slope. So to find the y values, I'll substitute 1 into the formula. So f of 1 is 1 squared plus 1, which is 2. And then to find the y value when x is 3, I'll substitute 3 into the formula. 3 squared is 9, and 9 plus 1 is 10. So between the points 1, 2, and 3, 10. So the slope of my secant line, f of 3 is 10, minus f of 1, 2, all over 3 minus 1. So the slope of my secant line is 8 over 2. The slope of my secant line is 4. So again, secant line slope should feel really familiar because they're slope. Now, instantaneous rate of change, that's where we're going to do more work. That, when you're finding the instantaneous rate of change, you're finding the slope of the tangent line. And we just define that formula right here. So the slope of my tangent line is going to be equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay? Now it says that the x value is 2. So that means I'm finding the tangent line at 2 comma some y value. So I'm going to say whenever I have f of x plus h, I'll be substituting in the 2 for the x's. So the slope of my tangent line equals the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. So then I'll need to find f of 2 plus h. So I'll just keep I'm finding the slope of the tangent line, so this is equal to the limit as h approaches 0. F of 2 plus h, I'm going to take this equation, and instead of x, I'm finding f of 2 plus h. So I'll be substituting in 2 plus h every time there's an x. So that would be not equals. f of 2 plus h would be 2 plus h squared plus 1 minus, for f of 2, I'm going to substitute in 2 for the x, so 2 squared plus 1 is 4 plus 1, which is 5, so the 0.25, so minus 5 all over h. So then I've got some algebra to do. Simplify the numerator. The limit as h approaches 0. 2 plus h squared is 4 plus 4h plus h squared plus 1 minus 5 all over h. Bring down. Still, you have to bring down the limit notation every single time. Can't, otherwise you're just doing algebra. You're not doing calculus anymore. Combine like terms. So I've got h squared plus 4h. 4 plus 1 is 5, and 5 minus 5 is 0, all over h. Then I can come over here, and I can factor out an h. So I'll have the limit as h approaches 0 of h times h plus 4 over h. And then I can divide out those h's to just have the limit as h approaches 0 of h plus 4. And when I substitute in 0 for h, I get that the slope of the tangent line is 0 plus 4, because you substitute in 0 for h, and 0 plus 4 is 4. So the slope of the tangent line at where x equals 2 is 4. So then part C says find the equation of the tangent line at x equals 2. And remember, it's at x equals 2, but we figured out that the coordinate was 2, 5. So if I know the point and I know that the slope is, I just figured out the slope is 4, I can write the equation of a tangent line by using that point slope form that you learned way back in Algebra 2 or Algebra 1, but it's y minus y1. The formula for that is y minus y1 equals m times x minus x1. So I substitute in the y value 5, not equals. So y minus 5 equals the slope of 4 times x minus 2. So then I can use my calculus, or not my calculus, simplify with algebra. Y minus 5 equals 4x minus 8. So y equals 4x. Add the 5 to both sides. I'm going to get minus 3. Then the directions say to confirm with your calculator. So on my Desmos calculator, I've graphed y equals x squared plus 1 and y equals 4x minus 3, my tangent line. And then if I look at the graph, I can see here is the parabola. And at the point where x equals 2, I've written the equation of the tangent line right there. And I can see that the line that I came up with is tangent to that graph at x equals 2. So I'm going to do one more example just like that so that you guys can see another one worked out. I'm going to skip example 2 because that's a line, and we saw earlier that a tangent line on a line is pretty much the same line. So we're going to skip example 2. It's not as interesting. So let's look at example 3. Example 3 is on page 9 in your notes packet. So this time we have the function x squared plus 4x minus 1. We're going to find the following, confirm on our calculator. So our average rate of change, which is again the slope of the secant line, from x equals -3 to x equals -1. So that means there's a point -3. We'll have to figure out the y, and the point -1. Find the y again. To find the y, I'm going to substitute -3 in for each x. So I'll find f of -3 to be -3 squared plus 4 times -3 minus 1. So if you substitute in -3 for x, I'll get -4 for y. And then if I do the same thing, but instead of substituting in -3 for x, if you substitute in -1, you end up getting -4 as well. So then to find the slope of my secant line, I'll do y2 minus y1, -4 minus -4 over -1 minus -3. So the slope of my secant line, -4 minus -4 is 0 over -1 plus 3 is 2. And 0 divided by 2 is 0. So the slope of my secant line is 0. Now, here's the big part. Let's find the slope of the instantaneous rate of change, which is the slope of the tangent line at x equals -2. So for reference, that's the point -2, comma, let me substitute in -2. So when I substitute in -2, the y value is -5. Okay, so the slope of the tangent line is a limit. Oh, I didn't do my subscript. The slope of the tangent line is the limit as h approaches 0 of f of x plus h minus f of x divided by h. Now, my x this time is -2, so this will be the limit as h approaches 0 of f of -2 plus h minus f of -2 all over h. So the limit as h approaches 0. -2 plus h, I need to substitute in -2 plus h in for the x's in the formula. So -2 plus h squared plus 4 times -2 plus h minus 1 minus f of -2, we said is -5, all over h. Then I'm going to do a lot of algebra. The limit as h approaches 0. -2 plus h squared is 4 minus 4h plus h squared. Distribute the 4, I get -8 plus 4h. And then -1 plus 5 is +4 all over h. So now I have the limit as h approaches 0. Combine like terms, I'll have h squared, -4h plus 4h, oh, those cancel. And then 4 minus 8 is -4, plus 4 is 0, those cancel. So I'm just left with h squared over h, and h squared divided by h is h, and when I substitute, this should be an arrow, the limit as h approaches 0 of h, substitute in 0, we get 0. That's interesting. Kind of frustrating that we did all that work and got 0, but we got 0. Then I need to find the equation of the tangent line at x equals 2. And again, the point is -2, -5. The slope of the tangent line we just found is 0. So I'm going to use the formula y minus y1 equals m times x minus x1. So y minus -5 equals my slope 0 times x minus -2. do some algebra to simplify. Y plus 5 equals, well, 0 times anything is 0. So y equals negative 5 should be my tangent line. And then I'm going to confirm this with my graphing calculator. I'm going to graph y equals x squared plus 4x minus 1. So there's the function. And then my tangent line has an equation y equals negative 5. And we said that the line was going to be tangent at the point x equals negative 2. So I go and look at x equals negative 2. There's a tangent line. There it is. It's right there. All of that work, and it all came together. All right, so you have an assignment on Delta Math about this. Good luck, and have a great day.